So mic check, check. Let me check whether I am live first. Yep, I'm live. So what happened earlier, no? I was doing the other stream and I was keeping on streaming, talking. And in the end, I realized that it is not being streamed. No, in the OBS, it shows that it is actually being streamed. But when I check YouTube, I don't see anything. I mean, it stopped at 30 minutes. And I think I thought I was streaming for like something around 90 minutes or 75 minutes, I guess. But yeah, whatever. But 45 minutes of proper streaming content gone waste. Not proper streaming content, whatever I did. But yeah, so I'll maybe brief you on that part. This will be taken as a continuous stream. So I'll maybe brief you on that part, whatever you have missed. So what is happening is I drew a sequence diagram. In the sequence diagram, what we see is in the main activity, we set a water cup view. And this water cup view is again setting a water cup renderer. And the renderer has a 2D screen object that is being created during on surface created or created of the water cup renderer. And there is first the init code that is being run on the 2D screen. And during the init, we initialize the vertex and texture buffers. And later we load the shaders, vertex and fragment shaders. Now, what is a shader? I think we have actually covered it in previous session, but anyway, I'll brief you. Yeah. So there are coordinates that is being sent to the OpenGL rendering pipeline. And after on processing the coordinates, we run the vertex shader, which is the whatever manipulation we have to do at the vertex level. So if you see the code here, this is code here. I'll just switch that screen. I shouldn't forget that. Every time I talk and change screen, I have to check via OBS that I'm actually changing the proper screen. Now, if I check the code here, what is being done is this is acting as a pass-through. At the vertex level, we don't do any sort of calculations here. If we see here, we just pass the text coordinate and we just pass the position, and we don't do anything else. We receive a couple of variables, we directly pass it. And then what is happening at the rendering pipeline now? At the rendering pipeline now, if you see this, after this manipulation, we have something called tessellation, geometry shader, vertex post-processing. And finally, we reach the rasterization. Rasterization is converting this 3D world, right? In which you have the triangles and which you have the coordinates. So by the way, for specifying the objects, the 2D world, right? We are using triangles. So as we have discussed already, for this particular project, what is being done is we have a screen. Consider this as a projection screen, which is basically a square that we are setting up in the 3D world. And then we are saying that we'll add some sort of image, which is a project to this coordinates. So image or texture, as we call in OpenGL lingo, is some sort of way of easily showing particular complex details, right? Otherwise, if there were no textures or images, we would have to even show them either via complex uh, manipulation of complex triangles, right? Now this thing has been made easy with the help of this thing has been made easy with the help of this images. And now, after we do the rasterization, which is the conversion of this 3D world into a 2D screen at the level of pixels, we run the fragment shader. And we can see the code here in our project. We receive what? We receive one, the texture coordinate. Color we are not using here, and two is the actual texture. So the texture coordinate, we are sending it via the 2D screen program. We can check it there. And this U texture is actually the actual image. Now, the texture coordinate is the interpolated texture coordinates, right? We basically pass, say, four vertices, and we pass the texture according to this texture coordinates according to these four vertices, right? Now, after which, what happens? After which, so we are only passing for the n for the vertices, right? In between, for the in between points, the program itself interpolates and gives you coordinates, right? So suppose if it is 0 0 for 0 0 0 0 and 1 1 for 1 1 1 1, the in between points are interpolated by the program itself, and for each pixel, depending on which coordinate it comes up to, the interpolated values are given. Now, for the image itself, suppose the image is of a higher pixel level or a lower pixel level compared to the screen that is being rendered, the magnification or shrinking happens with respect to the filters that we give. The filters that we are giving, we are actually saying it here, somewhere here, I guess. Min filter, yeah, not this one. Yeah, these are the stuff that we give. So basically, this is saying us if we have to map an image which will have x into x resolution to something that is bigger than this, right? So what we will use is we will use the nearest value, as in we will not interpolate for magnifying it. So suppose if the picture has resolution 320, and we have to show it in something that has of value, say 1040 into 1040. Now we will, for the pixels in between values, we will actually use this filter, and this particular filter will have for magnification, we are basically saying it is the nearest, right? So what it means is it will show it will not interpolate values. So if we interpolate values, what will happen is, suppose there are two pixels, one is having 0 and one is having 1, and there, suppose while magnification we have to calculate for three values in between. The in between values will have, say, 0.25, 0.5 and 0.75. So there will be a gradual transition in this case if we are doing a interpolation. GL interpolation option is there. So on a whole, that will have an effect of blurry pictures, right? As in, it gets blurred out. The transitions are not abrupt, they will be gradual due to this interpolation. And for nearest, what will happen is it will be more of a blocky kind of thing, right? So, instead of having a instead of having a crisp image, we will have blocky kind of image. The values will be either 0 or 1 only. But what will happen is it will be like less resolution on a very high image. So it will remain pixely or blocky kind of thing. But we have gone with this particular approach. The image that we are using is of higher resolution anyway. If you see this, it is 1080 to 1920. So I think this covers for most of the screens. Uh, but anyway, it wouldn't be such that it will be like totally out of uh, the image resolution area. And even if it is, it will not have a blurry effect. It will have this more choppy, pixely kind of effect because of the filter that we have added, which is the nearest. Yeah. So in this particular fragment shader code, if we see what is happening, we are receiving the U texture, which is the actual texture, and the view text coordinate value. And we are then using this to sample the texture, right? As in, we will just sample the uh, U texture to get the what will be the color for this particular pixel. Now we can see that we have flipped the y coordinate with 1. By the way, y coordinate will be of value 0 to 1, and actually -1 to 1, I guess. But uh, no, 0 to 1. Values 0 to 1, and we actually have flipped the y coordinate because by default y coordinate is taken from lower below the screen. As in, on the y coordinate start is being lower considered as the lower right hand corner is considered as the y coordinate start. So we have to flip it to actually get it to see the right way up. And yeah, and so basically we use the texture coordinate and we sample the texture, and we say this texture has this particular color. Now what is the next line of code? The next line of code is actually to make sure that we have identified, if you see the image, we have identified this particular what do you call this particular droplet. Okay. Okay, I did not change the. So this is the code here. The flipping is there, 1 minus vtext coordinate dot y. And there is a code if gl color dot x less than 0.87 and gl color dot greater than. This is to actually make sure that we are actually identifying the pixels that are having the drop values, as in this water drop values. And then we are just cleaning it up. Basically, we are rubbing it using an eraser programmatically for the droplet. And we can try this, check this whether this is working. We'll first run it with this and we'll see that the water drop is not present. We'll disable it and run it, and we'll see the water drop is present. See if the water drop is not present currently. I'll then disable it now. Now it's installed, and if I see the program, the water droplet is present correctly. Yeah. So our next goal is to get water droplet moving down. As in, now we are able to identify at the pixel level that the water droplet is moving, water droplet is present. Now the next goal is to get the water droplet moving it down. So one thing we are noticing here, we are not doing the processing at the vertex level, and we are not doing the processing directly at the pixel level. So this is one thing to take note of. Let me see if I'm still the stream is up and running. Droplet is moving, water droplet is present. Now the next goal is to get the water droplet moving it down. So one thing we are noticing, yeah, it is working, I guess. So I had an article for reference in this case. Let me just get that article up. Not for the water droplet moving per se, but at least the um, uh, at least the manipulation of textures. Yeah. So I'll just show the article. Yeah. So this is the article. Basically, it is using not Android OpenGL, but it's using WebGL. But in this, what they basically do is actually program a game of life. In this, using a fragment shader and a vertex shader. And you can see the game of life fragment shader. What they are doing is um, they are sampling the coordinates which are around this particular, as in diagonally above, and then diagonally on the left side, diagonally above, diagonally on the right, not diagonally, one row above, left side, one row above, and one row above on the right side. Then on the left, on the right, and then down one one row down on the left, one row down vertically down, and one row down on the right side. We are sampling these values and then uh, checking what are the exact values present. If it is 3, directly show 1 1 1 1. If it is 2, show as 0 0. If it is 2, keep the current one, and else show as 0. So sampling the 8 cells neighboring a particular pixel and making sure that we are showing a color of white or black based on the rules of game of life. This is what is being done here. But there are some things that I'm still not clear in this particular case. One is, what is scale? Why are we sending scale? Second is, what is R, right? Texture 2D dot R they are doing, right? I'm not sure what is that. Texture 2D dot R. R might be some, I have no idea what is R. So maybe we'll start with understanding what is R, right? This is the program for reference. And we also have a texture 2D, right? Texture 2D dot R. So we have two questions here. One is, what is R that is passed in texture 2D? Second is, that is not passed, that is param. Texture 2D. Second is, why do we pass a scale? Third is, how do we calculate the scale? These are the three things that are kind of in my mind currently. Uh, by the way, texture 2D is vec4.r, right? Vec4. Anyway, vec4, right? Yeah, this is R. XYZ is there. There are a lot of parameters. XYZ. W, R. Is R the RGB is R? Possible, I guess. Yeah, I think it is R is RGB is R only. I think it can be referenced as XYZW as well as RGBA. This is my understanding now. Okay. So basically R is the red component. RGBA value red component.